Welcome again to our webinar focused on SQL Server on a diet. This is a very interesting topic. We see these issues quite often with clients, and Rich Benner has prepared a informative and demo-rich webinar. And I should point out he's live from Derbyshire in the UK, and it's his birthday. He was gracious enough to host on his birthday with the promise to raise a glass afterwards. We'll give people another few seconds to join. Appreciate you joining us for this first webinar of 2024. I think we've given enough time. So with that, Rich, I think you can take it away.
Thank you, and you're very gracious to not say which birthday it is. Hello everyone, welcome to today's webinar. We're going to talk about data management, a few different topics, and we'll get to some demos at the end for everything I'm explaining. Tell you a bit about us and myself. So we're SQL Solutions Group. We're a full stack SQL Server consultancy. Long story short, if there's anything you need SQL Server, get in contact. We'd be more than happy to help. I'm Rich Benner. I'm a senior consultant here. I've been in this career path for around 16 years, and I'm performance tuning specialist. So the topics we're going to cover today: the need for data management. Why do you care? Why should you care? What does this mean for you in your day-to-day life as a DBA? The impact that data is likely to be having on your day-to-day, whether you realize it or not. We're going to go through a few different options on how we can manage our data. We're going to talk data deletion. We're going to talk table partitioning, archive tables, archive databases, database compression, and storing your data elsewhere, like blob storage. Then we're going to go through some ways you might automate your data management process, and some other things you might need to think about. And then we'll go through some demos to explain the topics that we've gone through already. So why do you need data management? So one of the things when we go into a new client or when we do a health check, we often see databases that are larger than they need to be. There may be some reasons for that, but it's a common thing that we see. Now, obviously, databases over time grow, they get bigger. That's what data does. That's what happens in our business. It may be a flat increase. It may be exponential if a company's growing, but data gets bigger. Unless we work out how to deal with that, it's just going to continue to grow and cause us pain, cause us problems. There are some things you need to consider if you're in a healthcare field. You might need to keep data for X amount of years. You might have other regulatory reasons why you need to keep data around. But we'll go through some options, if that's the case, about how we could deal with that and just make day-to-day life so much easier. So the impact of data on your daily life. The larger your database is, the longer it's going to take to maintain that database, whether that's your backups, whether that's running something like DBCC CheckDB, because I hope you are doing that. If you do index and statistics maintenance, these are all going to run longer the more data you have to process. Also, you need to consider things like availability groups. Are you in an AG? Do you need to make a change to your database that requires removal from the AG? That's fine, it happens. But then resyncing it to your availability group is going to take longer because it's bigger. Whether that's automatic seeding or whether it's backup and restore, it's all going to take longer the more data there is. You also need to think about your hardware considerations. We've all got X amount of hardware, whether you're on premise, whether you're in the cloud, whether you're on something like hyperscale, you've got X amount of hardware. Now, the more data you have, the more hardware you're likely to need to support that. An example is, let's say you've got one large table that's orders. You're a company that has a selling platform. You have a table which contains all your orders. Obviously, over time, they will grow. If somebody wants to select a bunch of data from that table, SQL Server will obviously let them. But that has an impact. That's going to I mean, storing the data in the first place is going to take storage, which nowadays isn't expensive, but it's not free. So it's something to consider. When you read all that data, you have to go through your network. You have to read it off your disks. You have to use your I/O. If you're in the cloud, that makes a difference. You have to get the data across your network. That takes time, the more data there is. When it hits your SQL Server, it's going to take up memory. It's going to use some of your RAM, which you may have plenty of, but it's going to boot some other things out of RAM potentially. So if we can reduce the amount of data we're processing, we will overall reduce our hardware requirements. So that's just something to consider here, and that's why it matters to you. If you could have a server half the size of what it currently is, it's going to cost you half as much. Some people care about that, C-level execs. So let's talk about some strategies you can do to deal with this data. The first one, the obvious one, is simply deleting it. You can assess in your own environment whether this is a possibility. Say you've got 15 years worth of history, how much do people ever query? Do they query data 15 years old? If they don't, do we still need it? If you could delete your data, just flat out delete your data, it's by far the simplest. There'll be no code changes. If there's a few considerations here. Just deleting the data in one big chunk is probably not a great idea. You want to delete it in batches. If you're deleting most of your data, a strategy for doing this would potentially be make a copy of your table, metadata only, copy the data you want to keep into it, truncate your original table, which is, again, it's a metadata change. It doesn't take any time. It just empties the table, and then copy your data back in. Obviously, this isn't an online operation. The data won't be available while you do this. So you'd need a maintenance window. But it's a really simple way of only keeping the data you need. And once that's done, obviously shrink your database files down. You don't do that regularly, but if you're doing a data deletion, you should. And then, yeah, the database, you can monitor it with whatever monitoring tool you have. You can look at your perfmon counters, and you can see it's just going to perform better with less data. It's just the way it is. There are some drawbacks with deleting your data. Obviously, you delete your data, it's gone, which may be fine, but that's, as controllers of data as DBAs are, that's a bit disconcerting at times. So you need to have a good think about whether it's appropriate in your environment. And again, going back to the healthcare scenario, because it's one we see often, is you need to keep your data for X amount of years. And for compliance purposes, you might not be able to just delete it. But we do have some other options in that scenario if we can't just delete it. And let's talk through a few of those. So one thing that's quite popular is table partitioning. And there will be a demo at the end. I'll show you kind of how this works behind the scenes. But what this effectively means is, and in most scenarios, we're talking horizontal partitioning, which means you take your table, you find a key that you want to separate the data upon. A lot of people use something like a date. Let's say, for example, you want to keep you care about the last 12 months worth of data. You can't delete older data, but it's often not queried. So what you can do is you can create a partition. Say you take 12 partitions, you partition your data by month. And then you have a 13th partition, which is everything else. So your archive partition, for want of a better word. What you then do is you create these partitions, you name them, you create the files, and then you give it a date range. And we'll do a demo, but basically you say, this partition I want to be from the 1st of January 2024, everything after that. And then you have one which is the 1st of December 2023, and you go back 12 months. So that each of your partitions contains a month's worth of data, and then you've got the old archive. This works well because in something like a sales operation, people are often creating sales and then querying the same data, and that's the last partition. That's going to be the most active, but it means you're only dealing with a month's worth of data rather than your entire history table. And there are ways of potentially indexing around that, but unless people don't have access to query your data, it doesn't take much for somebody to forget a where clause and select a load of data, and then you've got a problem. Now, what you can then do once you've got your data into 12, 13 partitions is they will each have their own NDF file behind the scenes. You can put them where you want. It may be that you have, let's say you have 3 tiers of storage. You have a nice fast disk over here, and then a medium tier, and then slow disks. You could put your latest partition on your fastest disk, put the other 11 on your medium disk, and then put the archive on an old slow disk. And what that means is that, yes, when somebody queries that oldest data, it might be slower, but that may be 1% of your workload, people querying old data. 99 is the current month. So having that on the fastest disks, and this works in a virtualized environment as well, because improving the performance of a disk isn't free. What it allows you to do is put your old data on slower drives to save money effectively, but the data is still available. And you can do that however you want with these files, as long as you declare it when you do your partitioning. You can literally do whatever you want. Now, we will cover this. You will have to do some maintenance for if you do have like a rolling 12 months. You need a process once a month, which can update, create a new partition, get rid of the old partition. But that's something you set up once. You make sure it works. You monitor it with something like a monitoring tool to make sure it is creating your new partitions. But then that will just, that's an automated process, and we'll go through that later. Some more advantages of partitioning. You can do what's called partition swapping, where you can have a partition that contains data, and you can swap it to store it elsewhere to a different table. It's just a metadata change. It's just a really nice way, especially on larger data sets, of just swapping data in and out if you need to. It's fantastic. You need to consider, you may need to look at your indexes and or create a supporting index, and it may require code changes. Now, the reason for this is, and this is a fairly meaty bit of topic, so I'll try and cover it quite quickly, is I mentioned you create a partition key based upon a date. Your queries, in order to take advantage of the partition, need to query on your partition field, which in this example is a date. So if I'm querying order data, I need to query for a date, or that I need to search for data within a certain date range. Otherwise, it won't use the partitioning correctly. Because of that, it may need some code changes to make sure your queries are doing that. Alternatively, if you do something like, if you're always querying on an ID field, so an identity, a surrogate key, if you're always querying for order ID X, order ID Y, whatever, you can partition on that. It's not as simple for humans to understand as a date. So you can see there's a month's worth of data, but let's say you've got 100 million order IDs. You can partition that by 500,000, 1 million order IDs. So you have a partition that's your last 12 million. You have 12 different partitions, and then anything before then. And that number might be different for you. It might be billions, it might be hundreds. But you can set a range of IDs. If that's how your code base is written, you can do that. Alternatively, you could create them for months, and then at midnight on the 1st of every month, you can find what your max ID is and then partition based on that. So there's different ways of doing it. It's very flexible, but it's often not something you could just implement, set and forget. You need to think about it. So whether that works in your environment, I definitely recommend looking into partitioning. Let's look at some other things if that's not suitable for you. So another common thing we see is archive tables. And what this basically means is you take a copy of your table metadata, you create a new table. Let's say it's orders, and you might create an orders underscore archive or underscore history or whatever naming convention works well in your environment. And then what you can do, you can decide, in my live table, I want X amount of data. I want a year. I want a month in my currently active data. This is hot data. This is data we're either writing to or updating or reading a lot. This is the date range that I want in my main table. You can then take any data that falls outside of that range and copy it to an archive table and then remove it from the original table. That way you still have the data there and available. But if somebody wants to query the older data, they will have to query it a slightly different way. Whether that be a union between your live table and your new table, a union at all, because we want on the dedupe, or whether you create a view that sits over that does the union. So they could either query for current orders, or if it hasn't got the data they need, they write the query that joins to the table, or they hit the view instead. What this allows is that most of your queries, like your live queries, you're running your active data is all in the one table, and it's much easier to maintain because you will have to do maintenance on these. Any maintenance you're currently doing around indexes, around statistics maintenance, anything like that, you will have to do on both tables, but likely your system already automatically picks them up. But the theory is the other table, the archive table, won't be being modified often, so it won't require the maintenance. And when you do the maintenance on your live table, you're only doing a month or a year's worth of data, not all of it. So that goes back to improving the performance of your maintenance jobs. And again, these tables can be made on a different file group, so they can be put on cheaper storage. And they can be different. The metadata wants to be the same as your primary table, purely for the case of when people union them together. It'll be much simpler if they've got the exact same structure. But let's say your live table needs a lot of supporting indexes. That increases your data volume. The amount of space it takes on disk. Indexes are basically a copy of your data. Your archive table, you might only want, for example, a one clustered index on there because you query it so infrequently, and that will reduce your overall database size. And then going back to something like backups and check DBs, those will just go faster. One thing that you would need to consider, so generally the way we see this implemented is people have a process that runs nightly or weekly or monthly. And what that does is it finds any data in your main table that's past X amount of days ago. Let's say it's a month. You might have a process that runs once per night that goes anything older than a month, I will copy to the archive table and delete from the main table. And that's fine. That's absolutely not a problem. But you would want a process built into there to check that you haven't got any missing data. And that's quite easy if you're using something like a surrogate key, like an identity field, to check if there's any IDs missing, if there's not supposed to be, or check that you haven't got duplicate data, because once somebody unions those tables together and you're returning rows twice, that's generally not appreciated by the business. So yeah, you can absolutely do archive tables, but again, it's not a no-code solution. It's a no-code solution for most queries because they only care about current data. But for people that want historical data, for example, reporting teams, they might have to change their code to looking at a view you've created, which does the union for you. And consider if you put it on slower storage, that query will run slower. Might not be a problem for reporting because generally big reporting queries run overnight anyway, but it's a consideration to think about. You don't upset the BI team too much. A slightly different approach, but very similar, is archive databases. So where you've got, instead of creating a table in the same database, which is the archive, create an archive database. Now, the process of moving data into the archive database is very similar. Retrieving data from the archive database, again, very similar. But what the advantage this has is, say you have the process to move data that runs once a month, and it finds anything older than a month, moves it to the archive database. You only need to back up that database once a month because the data isn't changing in it. That reduces your overall backups duration. So if you need to run those out of hours, if you've got a slim window to run them in, because data is only modified once a month, index maintenance, statistical maintenance will only run once a month if it needs to. And yeah, that's going to affect your overall maintenance. It's just going to be sleeker. One thing that you can do here that I've seen implemented before is going back to, I'm going to use healthcare as an example again. We've got to keep data for X amount of years, and that number is not set in stone. Sometimes it's 7, 10, whatever. People in healthcare tend not to delete data because it's safer not to. That doesn't mean you need it on an active live server and available. You can archive data into a database, perform a database backup, and for compliance purposes, you've still got the data there. If somebody wants it, you'd have to restore it to a server and access the data. And just as a slight aside, if you're doing that, you need to ensure your backups are being verified once they're done. And what that means is you do the backup, you restore it to another server to check that it restores okay, and make sure there's nothing up with the backups, because until you restore your backups, you can't guarantee they worked properly without some sort of bug. And you definitely don't want that to happen if you need to retain data for compliance purposes. You could do that, and whether you keep that database online or offline, it's up to you, but it's another option of moving it elsewhere. And I've got some example data, but on my test database that we're going to be doing the demos on, I'm using the Stack Overflow 2022 database. And that is a copy of the database from the website Stack Overflow. But it's everything from its inception, which I think is 2008 off the top of my head. It's around then. All of the history up until 2022. That's about 430 gig, I think, the test database. Now, backing this up on my laptop, on my test system, bearing in mind it's local M2 storage, because storage is often the bottleneck, network and storage, when it comes to performing backups. Considering it's local M2 drives, which is going to be pretty fast unless you're on some very good hardware. I'm not dealing with network at all. To perform a backup on the live database, it takes me just over 20 minutes. What I've done is, in one of the examples I'll show you, but I've retained a year's worth of data. I've copied the database. I've retained a year's worth of data. I've then performed a backup on that database, and it took a minute. So scale that up. Consider maybe you don't have local SSDs on your server, so you're in the cloud. You've got to deal with the network. You may have larger databases of 430 gig. We see terabytes easily out there. Reducing your backups by down to 5% of what they used to take is significant. And that just helps you perform your maintenance and look good to the business. Because backups are an online operation, but they still put a stress on the server. So they may well slow your system down. But if your backups are slick and you can then verify those backups work nice and fast, then that's only a good thing. So again, it depends on your situation as to whether you can do that, but it's a great solution if you can. Before I keep going, I realize I've talked for 25 minutes so far. Jason, do we have any questions?
There was a question which Scott actually jumped in to answer, so that's handy. And you've had some well wishes for your birthday too.
Yeah, thanks. I don't like the attention. Okay, cool. I'll carry on then. Right. So another thing, if you can't move data out of your database, you don't want to move it into new tables, you could consider compression. Now this it's basically like turning your database into your database tables into zip files, right? And there's different ways of doing that. And in fact, I've got a demo. I'm just waiting for a query to complete. Yeah, perfect. Row and page compression, they are very simple settings to change on. They don't have many requirements in order to switch them on. Obviously, by compressing your data, it will take less space on disk. The downside of that is if it's a table that's active and you're inserting data a lot and reading a lot, then compressing and uncompressing your data does have an overhead. So it's not something in every environment you just want to switch on because it saves disk. Obviously, everything you do, you need to test the performance of your reads, your writes, and your overall. That's going to take more CPU to compress and uncompress. So if your bottleneck in your environment is a CPU, then you definitely want to closely monitor that if you're going to consider row and page compression. The one that in the right scenario has an enormous impact is column store indexes. Now, when you talk about row and page compression, you're talking about compressing a single row of data, or you're talking about compressing a data page, which is 8,000 bytes. You're talking about compressing that down if you can. But that is basically working at a row level. What column store indexes do is they compress vertically. They compress columns. Now, this can be very handy. So a system I've worked on before, we went in, there was a history table which was required. It needed to be kept for compliance purposes, but it was a lot of replicated data. So it was a list of it's like a history of changes. But in certain columns, and when this individual table was about 450 gig, one table. But when you looked at the columns, and bear in mind, in this there was no max fields. It was just a lot of data. It was billions of rows. In certain columns, there are only maybe 15 different options that could be in there, 50 different types. That table we assessed. It was built by an overnight process, so we didn't have the concern of inserting and reading from compressed tables. We applied a clustered column store index, and I'll clarify what cluster column store indexes are in a second versus non-clustered. But that took the table from around 450 gig for one table down to, I think it was 14 gigabytes for one table. And obviously that's just a massive saving when it comes to storage and then storing that data in memory and things like that. I realize I haven't clarified what a cluster versus non-clustered index are, and chances are if you're here, you know what they are, but I'll cover them anyway. A clustered index is ultimately the page. There are two ways the table. There are two ways of storing a table on disk. It can have a clustered index or it cannot. If it doesn't, we call them heap tables. This is just how it's stored on disk. So if you think back, if you're old like I am now, and you remember things like disk defragmenter in Windows 95, if you picture that, a clustered index will be stored all neatly on disk. A heap table stores wherever. When you insert data to a heap, it'll just find space on this and chuck it in. It could be stored all over, all fragmented. I won't go into the advantages, disadvantages, but that's what we're talking about. So on this table, by adding a clustered column store index, we took the old table, we clustered column store, and it reduced the actual table size to 14 gig. Now, a non-clustered index, you can have, I won't say as many as you want. They could have hundreds, but you really shouldn't have that many indexes. You should have a handful. You should be able to count your indexes on one hand, ideally. But you can create multiple non-clustered indexes, and one of those can be a non-clustered column store index. But what that doesn't do is reduce your table's overall size on disk, and that's what we're focusing about on this webinar. There are different advantages to non-clustered column stores, but I won't go into that because it's kind of off topic for what we're talking about here. But if that interests you, by all means, you can pop us a message. I will give you plenty of reading, and we can totally have a chat about different types of indexes. I love talking about that nonsense. But yeah, a consideration for this is it's very much data dependent. The example I gave had a lot of rows that had lots of duplicated data. When you consider it between rows, it compressed really well. I've seen it not compress tables at all because it's lots of unique data. It's in the example demo that we're looking at, we have a users table. There's not going to be much duplication in a users table. It's going to be people's names, addresses. People may have signed up more than once, but username, user ID, things like that are all going to be unique. So it probably wouldn't compress that well. So it's something you need to assess. And there's a website, a Brent Ozar website called a column score. You can go on, you can put in some details about your table. It'll tell you how well column store would work in your environment. So if you're interested, again, drop me an email and we can absolutely talk about that. Right. There's another option we have, and this is relatively new in the grand scheme of SQL Server, but it's storing data on blob storage. Now, blob storage, I assume you all know, but I'm going to cover it anyway, is something like it's usually in the cloud, and each provider has their own flavor of blob storage. For example, AWS has S3 storage, and it's just a file system you can use to store data. Now, it's not somewhere you can store databases, or that you'd want to rather store databases, but it's usually cheap as hell. Now, what you can do is if you decide that, yes, I need to keep this data for compliance, for example, or I just don't want to delete it because it makes me nervous. I completely understand, by the way. But I also am under a lot of pressure on my server. I don't want it on my SQL Server. You can actually store it as text files. You can store it as CSV, XML, JSON, whatever format works well for you in your environment. You can export that data. Now, a tool that is built into SQL Server, which is great, is Polybase. Polybase is designed to be the feature that allows you to query data that isn't in your database. Now, it can query other databases that aren't Microsoft SQL Server databases. There's a list. I won't give a list because it might change, but if you go and look at Polybase, it tells you where it can connect to and what drivers it has. But it can also connect to things like AWS S3 or Amazon Blob Storage, or whatever Google's one's called. But you can export your data over there and store it. It costs pennies on the dollar to store data in there. And via Polybase, you can still query that data. As a DBA, it's a little bit disconcerting that you can do this, but it's really useful. You get the advantages of reducing your database size. You get the advantages of the old archive or history data is stored very cheaply, and it's still queryable. Obviously, you'd have to write your queries different in order to retrieve that data, but that's not a huge deal. Scott, another one of our senior consultants here, did a webinar about this. There's a bit.ly link, or if you go to SQLsolutionsgroup.com, go up to the top and look for webinars. You can find a list of our history webinars. You'll find this one on here. And you can go back and watch Scott explain what Polybase is, how it works, how it queries the external data. It's fascinating. Polybase is, just in case you're not aware too much of it, think back to when you install SQL Server, you can install the engine, you could do SSIS, SSRS. Polybase is very similar to that. It's a feature that you can install on your SQL Server. It creates a few. It creates 3 databases that it uses to control everything. And if you don't have it installed, you can do it via the upgrader. You can add it as a feature. I'm sure you've all done that, but it's really good. It's not perfect. If you watch Scott's webinar, he'll explain the pros and cons. But it's a really neat solution if you don't want to keep the data in your SQL Server or in SQL Server at all, but you still want it to be around. You can chuck it into blob storage and then it's just there. It's a text file. Now, it's just there. It's a text file. Again, might be a concern. If it's just stored in plain text in Amazon Blob Storage, it's secure. You have to go in through. You have to go in with Amazon. You have to go through the console and what have you to be able to access that data. But you definitely want to consider the data security. I don't consider it an issue, but if your company's particularly if they like avoiding risk to the extreme, I'll say it politely, then yeah, you'd have to take that consideration into account. Now, with a lot of these, I briefly touched on this before, but you as a DBA don't want to be doing this manually. To set it up, obviously it's going to have to be manual, although there are some tricks you can do. But the daily, weekly, monthly maintenance, you don't need to be doing that. You don't need to be waking up at 2 in the morning to do some maintenance on the partitions. The way we see most people who've implemented any of these solutions, and this works for any of them, is doing something like creating an agent job, and whether that runs code itself, whether it runs a stored procedure, which does some work, whether it runs PowerShell, you can do it however you want. But what we tend to see is, let's say you have a monthly partition. Then before the end of the month, you'll have a SQL Server agent job that runs once a month. It will delete your old partition. It will create your new partition for the upcoming month. It's a bit more involved than otherwise, but setting it up, you want it to be reliable. So you want to put some effort into this, but once it's done, it's done. It should just run. Obviously, you need to monitor it if you have a monitoring solution. If not, if you just have SQL Server, then you want to set up, make sure you get an email if an agent job fails, so that you know that something might have gone wrong. Things break. It's part of life. That's why we're here. So you want some monitoring, but yeah, you want to invest the time to create an automated process to do this all for you. And again, that doesn't matter if it's daily, weekly, monthly. You don't, just automate it. So the next thing we'll do is we'll go through some demos and show you of the topics we've covered. I'll give you some examples. Before we do, any more questions, Jason?
No, sir. Oh, I did.
Okay.
I posted a link to Scott's webinar in the chat, so it's easy for people to click on.
Perfect. Yeah, so that'll be in the chat. Again, you can go to our website and it'll be in webinars as well, if that's easier for you. Thank you, Jason. Right, okay, so let's do some demos. Management Studio. Just for reference, I'm going to set statistics on. If you're not sure what that does, I'll show you what it does. We're going to set some statistics so we can actually gather some metrics. This is the Stack Overflow database here. Now you can download it from, I think it's data.stackexchange.com. You can just go and download the text files and load them into a database. This is the amount of data we're working with. So these are the tables, votes, comments, posts. Obviously, it's a question and answer site. People will post a question, people will comment on it, people will vote on it. And this is the data volumes. It's 430 gig, roughly. The biggest tables post history. Now, I've written an example query for this, for the partitioning. Now, it's worth noting, this data, like I mentioned, is only up to 2022. Purely because we're not working on a live database, it's a demo. So if this was live data, I'd be looking at data within the last 12 months. For the purpose of this demo, I'm just looking for 2022 or later. What this will do, it'll find us all posts and the count of comments it's had against it. It's very simple. Anything that's happened in 2022 and order it by the creation date. Now, I'll run this, but I've got an example of a query plan here. It takes a couple of minutes to run, so rather than make you wait. So this is the same query here. By the way, if you don't recognize this software, it's called SentryOne Plan Explorer. It's free to download from SentryOne, and it is excellent when you're looking at query tuning, query performance, and execution plans, and things like deadlocks. It's fantastic. Highly recommend it. Absolutely free. So it's just the one statement. This is our statement, and this is our execution plan. And I'll quickly go through here. Basically, what this is doing, as SQL is a declarative language, I'm not even sure that's a word, where you declare what you want and you don't tell it how to do it. It decides how to do it behind the scenes. It's the query optimizer. It decides how it's going to join the data together. So what this has decided here is we're hitting the comments table. We're reading 85 million rows of data. We're doing it parallel because my parallelism settings allow that. We're grouping it up, we're sorting it, and by the end of what we've done with the comments table, we're still up to 28 million rows. We're then looping through and joining that to our posts table here. And you can see finally we have 700,000 rows of data produced. Now, there's a query cost here. You can see the estimated subtree cost, the fourth row, is 7,500. Now, that's just a number nowadays. It used to be the amount of seconds that a query to execute that would take. How long would it take to execute this query in seconds? But that was on a particular machine at Microsoft headquarters in 1996 or something crazy. So nowadays it's an abstract number. It's just used for comparison purposes. But let's remember 7,500 query cost for this. And you can see how much data we're having to process here. That's a ton of data. You can see here it took dead on 2 minutes. And the same execution plan. Now, just to quickly show you, when I set the statistics and time on, what that does is it gives us some data in the messages tab. And that tells us the number of rows affected. And for each table that it's using, how many things like reads it does. And reads is a really good baseline to focus on here, logical reads. Logical reads is data read from memory, physical reads is data read off disk. So you'll often see many more logical reads than you will physical reads. But it also gives us things like the elapsed time in milliseconds. Now, I don't know about you, I can't read this very well. So what I tend to do is go to statisticsparser.com And what you can do, and I'll clear this to show you. You take this messages tab, Control A, Control C, you paste it in here, and it just passes it so you can read it nicely. You scroll right to the bottom, and you can see this took 7 minutes of CPU time. Remember, it ran parallel. It used more than one core. So my maxed up setting on this is 8. So it can use up to 8 threads at a time. So for every real-time second, this can use 8 seconds worth of CPU. So that's why CPU is higher. And it took 2 minutes to execute. But you can see here, and we won't go into what work files or work tables are. They're just internal temporary tables. But you can see we're doing 167 million reads from the posts table and 2 million logical reads from the comments table. And this isn't rows. This is 8K data pages. You can have more than one row on a data page, depending on what data is stored there. So that's a considerable amount. And you can see most of them, I mean, it's obvious, most of them are from the posts table. So let's remember that. We'll come back to that in a second. So this query takes about 2 minutes to execute. It's fairly simple, but it does a good example of here. And you can see it varies slightly depending on workload. But what I then did is effectively this query here across all the tables. I created a database called Stack Overflow Slim, which is an exact copy, but effectively I deleted everything that's a year older than the maximum date. Now remember, I can't do anything that's a year older than today because this isn't live data, it's demo data. But I found the latest date in the votes table and found everything that was within the latest year. Now, I obviously didn't just run this, and I say obviously, if you run this, that's going to be one enormous transaction. It's going to bloat your log file. You'll probably run out of disk space. TempDB will complain because you'll be spilling to all hell. You want to do this in loops. So you want to find out how many rows you need to delete by doing a select count. Divide that by batches of whatever works in your environment, 5,000, 50,000, a million. Doesn't really matter. You want to be doing it in smaller batches. But the result is this. And I ran this across all the tables in this Slim database. Now, if we compare the data sizes here between the two databases, I selected too many rows. You can see this is our original table where we've got lots of data, and down here we have considerably less. The one table I didn't truncate was users, because users persist, and it didn't make sense to delete older users because users hang around. There's people like John Skeet, for example. If you spent any time on Stack Overflow, I'm sure you've seen his answers, where he's been around forever. He's the most active person. He's still around. So I didn't delete old data from users. Sorry, yeah, from users and from votes. No, from users. I did delete votes, which went down from 230 million to 18 million. Post history, from 150 million to 10 million. So just by that, you can see that we're dealing with a lot less data. And these are the amount of rows we had. We've gone from 600 million to 60 million. So we've reduced by 90%. The database size went from 430 gig down to 35 gig. So that's more than 90% reduction in the amount of data we're dealing with. Now, I'm aware this is hard deleting data, but for the purposes of storing data in another database versus hard deleting versus things like Polybase, this is effectively you're going to get the same result. So for the purposes of this demo, and I mentioned about backups. So backing up our 400 gig database takes 20 minutes, 21 minutes on this machine. When I slimmed down the data, it took 1:17. And that's going to affect all of your maintenance the same way. Index, check DBs, things like that. If you're dealing with less data, you're dealing with less data. It's going to take less to work. Now, what I did was I ran that original query, and then I ran the same query against our slim database, and I'll run that, but that's going to take a few minutes. So let's go and have a look here. So this is our query before. You can see 7,500 query cost. We're dealing with hundreds of millions, tens of millions of records here, thousands here. It's not great. Now compare that to the slim database. We're still dealing with millions, but we're dealing with 5 million rows from comments. We're dealing with the same amount from posts, because posts is posts. But if we look at the subtree cost here, you can see it's gone from 7,500 estimated cost, query bucks, whatever you want to call them, down to under 1,000. So it thinks it's going to be 7.5 times more efficient than before. And you can see it's exactly the same query, and it does estimate out to the same plan with how it's going to do it, but it just performs so much better. Now, these things won't have completed, but when this does complete, it's very interesting as well. It's a good example where these are the same queries run against the same tables. One just has less data. The second query that's run against a slim database asks for an index, which is going to improve performance by, I think it's 82% off the top of my head, which the full table couldn't. It didn't realize it needed an index to support it. So what you'll see is the original query takes around 2 minutes to execute. The new query takes around 10 seconds to execute. And you can see the amount of CPU we're doing, the amount of milliseconds, that's over 5 minutes of CPU. Whereas this is using a second of CPU, the smaller one. Oh, here we go. The big one's completed. You can see overall, like with the longer, larger running query, it can't even ask for a supporting index. So you can see the same results. If you go look at the execution plans, you can see the original query is 7,500. The new query is 960. But what this index hint here is saying is, and this is just an estimate, but it's saying that if you create an index on creation date and include title, I will be 86% faster. So we're already down from 2 minutes to 10 seconds. This is saying if we run that index, it can go even faster. And in fact, we can even do that. We'd never leave the name in here, but for the purposes of this demo, let's leave the name in there. That's going to take a little while to build the index. There we go. If we go back and run this query here on the slim database, it's going to have to load it into memory first time, so it might take a second. I mean, that's down to 5 seconds. Run it again. Okay, 4 seconds. But if we go back to statistics parser, in fact, I didn't show you this before, but the original query was taking 169 million logical reads. The slim query is taking 1 million, which is an enormous difference. But this new query here, with the additional index, is doing 150,000 logical reads. So we've ultimately, by deleting old data and by adding an index, we've gone from 169 million logical reads in 2 minutes execution. We're down to 150,000 logical reads and 4 seconds execution, 5 seconds. So this is the sort of impact it can have if you get this implemented. And that's one of the reasons. It's something that we see often. It can be difficult to implement, it very much depends on your environment, your data, your policies, your compliance. But there's significant improvements that could be made, and we see it often. So we're about finished. Long story short, the conclusion is data management should matter to you. If it doesn't now, it really should. If you want to be good and you want to be a valued DBA, you need to be taking on things like data management. I'm not saying go and implement this tomorrow. I'm saying you need to put a strategy in place to go and assess your workload, assess your data, and decide which option is best for you for dealing with this data. It's a project, but it will make your servers faster, people never complain about servers getting faster. It'll make them slicker, so potentially save money by having less hardware. And if the worst happens, if you lose a database, if some corruption happens, if you need to recover a database from a backup, if your database is a tenth the size, it's going to take a tenth the time. So you absolutely should consider this. So we've got so that about wraps up for this webinar, and we'll go to questions again in a second, see if there are any. We've got another webinar coming up on March 20th, where we're going to be talking about SQL Server anti-patterns that we see, and a lot of T-SQL common mistakes we see. Obviously, we do a lot of health checks by the business that we're in as consultants, and there are things that come up often. We'll go through the most common, the most impactful, and we'll give you the tools to be able to not make those mistakes in your environment, or to identify and fix those mistakes. So that'll be on March 20th. You'll get an email if you've attended this webinar with some details about that. Alternatively, keep an eye on our website and we'll be here. So is there any more questions, Jason?
There are no new questions, Rich.
Okay. I'll give a minute or so. If anybody has got any questions, by all means, pop them in the chat window. I've got a dog under my arm who's waiting to go out for a walk. I don't know if you can see him. This is Dave.
As Rich mentioned, we'll have an email out to you very soon with the details for the next webinar, and probably in a separate email sooner, meaning tomorrow, we will have a link to the recording for this one. So we make sure everybody has that.
Yeah, and we'll also get you the slides and the demo scripts as well.
Correct, yes.
Yeah. No more questions?
No, I think we could probably give everybody our thanks and say good night or good afternoon or whatever the case may be.
Good evening, yeah.
Okay.
Right.
Well, thank you, Rich, and thanks everyone for joining. And yeah, as mentioned, you'll get information for the next one pretty soon. Appreciate your time.
All right. Thank you.